it's been for me.
Face for radio,
Yeah.
which you've, reliably done the radio for what, 20 years?
20,
However long it is.
26.
Yeah, I'm showing my age. Remember. I'm going to blame it on the pandemic.
Yeah.
The pandemic threw everything off by a couple of years.
Yeah, everything's either last week or 20 years ago.
Yeah.
For a while, that's what it felt like, didn't it?
I know.
It really did.
We are up and running, so whenever you want to
Okay,
start, go ahead.
welcome to our discussion. I want to begin by, first of all, thanking Pete and Patrick, going to do the second half of the discussion today. But I also want to remind you that next week we will start at 11 a.m. It'll be immediately following panel discussions, which, frankly, Pete and I were just talking, we hope devolve into sort of nothing going on from 10:30 to 11, so we can set some of the technology up. But those panel discussions will be taking place in 8:11, 8:23, and 14:11, where the synoptic dynamic discussion will be going on. I forget which one is which, but 8:11 will either be the satellite meteorology and oceanography, and 8:23 will be climate science or vice versa. But that's what's going on. So feel free to sample them all. You don't have to stay at one. And it's supposed to be free-ranging conversation. The panelists will begin by giving a few comments, and I've tried to instruct them to make sure that they're not lectures, so they're not long, and that everybody who attends can contribute and have some fun talking about some of the issues that we've done over the last 75 years in this department, which is really quite glorious. Okay, so that's the announcement. Next week we'll start here at 11, and I think former Professor Morgan, or on leave Professor Morgan, I don't know how I'm supposed to announce him, I think he's going to be here and probably be part of the discussion. So that will be very fun, as it always was when he was around, so that'll be cool. And we'll also have the former director of the National Weather Service in attendance, probably even involving himself in a fairly high-profile way. So that'll also be fun. So it should be a really good time.
And if it's full in here, we're planning overflow at 8:23.
Oh, yes.
So
8:23.
that'll be on the screen in there.
So there'll be other places to watch, and on Zoom, right? So that if you're in the other room, no, all of you know this, get here at 11:15, so that you get a seat. I mean, that's the home field advantage. But if for some reason that doesn't work out, I think Pete said it's going to be on Zoom, so questions will also come from the other room.
They'll be on Zoom and on YouTube as we always do. But
Yeah, but the Zoom
more
will be
interactive
kind of
with this,
constant, immediate contact. Okay, so let's start with our discussion for today. The first thing that pops into my mind, because there was a period of time this morning where we had oscillating thicknesses of the fog. It was really quite remarkable. There was one point, I don't know, it was probably about 9 o'clock, I looked out my window to the southwest, which is, this is a nice time of year to do it because you can see the different species changing color. Just like in the spring, you can see them leafing out for the first time. They don't all come out at the same time because they're all in competition. And boy, there was a lot of fog. But look at it, all over the place. This is western Nebraska. Look at that, it looks like cloud, but of course that's low level fog. And it's all the way in the northern part of Illinois, and you can see it also through the higher clouds, which do exist over us in the southern part of our own state. So a foggy morning, first foggy morning we've had in a very long time, if I can recall right. So that's interesting. Now, looking at this map, or this satellite movie, one would say, boy, there's not that much interesting weather going on around the country, but that's actually not true. We're going to look at some fairly heavy precipitation in the sort of northern part of the middle Atlantic states today. They had flooding in New York City on the streets and downstairs into subway stations, which is a real threat for them when they get heavy, heavy rain. Where's this coming from? Well, it was a recently departed beast from us. We had a really rainy, kind of autumnally rainy week. However, tropical week, if you ask me. The dew point flirted with 60 all the time, all week long. In fact, it was mostly over 60 at the end of September. So this is a very dynamically impotent system, but thermodynamically supercharged. A lot of water vapor in it and stability is low, and that was one of the reasons why we were so rainy much of the week. So very interesting. It would have looked like something you'd never write home about when you look at the weather maps over the course of the week, but this thing has dropped a lot of rain over the northeastern part of North America. I'd say this whole region here, including us. So we'll talk a little bit about what's going on there now. It's an interesting structure. We'll say a little bit about the tropics. We've got a couple of disturbances simultaneously as tropical storms right now. And it's raining fairly heavily across parts of Minnesota. We'll see that in a minute. This also is not obviously well connected to a deep cyclone, but you'll see that the dynamics that are involved in producing this precipitation are not difficult today to discern. So I think that'll be fun to look at that. There's a very impressive storm at the end of the Aleutian chain, which we'll spend some time talking about. And then just generally, the Northeast Pacific is looking a little more energetic now in terms of mid-latitude disturbances than it has for much of the first 3 or 4 weeks of the term. So, and the final thing is smoke, from what might be at least some never-ending fires in northern Ontario. Now, I think these are the same ones, maybe some of them, that were there in June. And so you can see this thick pall of smoke across the Bay of Fundy, parts of Nova Scotia, and northeastern Maine. So pretty brutal. And look at how far out it goes. It goes all the way out to about the longitude of Greenland. So pretty unbelievable. This is, I'd like to know, Patrick made a guess last night that, or yesterday afternoon, that this was fairly high elevation smoke, and it may well be right. But I'd like to know where it is. Where's the density most intense? It'd be kind of cool to know that. So can't really tell here, but fairly stationary over 6 hours in this plume right here. It's just not moving. So one gets the impression that it's maybe funneled by a northerly flow at high levels, not a horizontal flow at low levels. Okay, so those are some of the touchstones that we'll look at. Before we leave this picture though, broadly speaking, much of the continental United States is enjoying a fairly nice late fall or early fall day, late summer day. A little bit of exception here along the Gulf Coast, across the peninsula, and then we'll talk a little bit more in detail about what's going on in the Northeast and also just to our northwest before we go out to the Pacific. So let's take a look at, just to get your appetite whetted, let's take a look at the Pacific satellite movie if we could, Pete. And maybe the infrared's the best at this time of day. Yeah, so this is the beast of interest. Look at that thing. It's just at the end of the Aleutian Islands, so just barely in the Western Hemisphere, and very intense cloud streak associated with the cold front, which will be obviously lined up with the thickness gradient. You'll see that nicely. And then the cloud head to the northeast of that, and even some wraparound cloud, which is forced by the dynamics in the occluded sector. And you've got this cyclone center, which is very obvious, spinning around just south of the Aleutians. I think the sea level pressure is in the 970-ish range or something like that. So this is a real beast. First good one of the year. And then a parade of little disturbances has made their way across the northwest coast of the United States. This is number 2, isn't it, Patrick? We had one earlier this week that was a little more robust, but very short-lived. It had a burst of dynamic activity on Tuesday, Monday night into Tuesday, and then it dissipated. I don't even know where that circulation center is. This might be some of the cloud debris associated with it. This second one here is maybe even weaker and not as well organized, but still discernible in the satellite picture. And we'll try and see what the link between these disturbances is, this one being downstream of the more impressive one that's at the Aleutian chain. So we'll say a little bit about that. Pretty interesting. Okay, let's now take a look, if we could, Pete, at the radar summary over the continental United States. We see a little bit of cloud on the southeast, a little bit in the northeast. What's it all doing? So here's the spotty convective showers that populate parts of the Gulf of Mexico and are sort of straddling at this stage the peninsula, but a little bit here north of Fort Lauderdale, Cape Kennedy. So it's raining just off the coast in both coasts of Florida, and then the same is true in the northern part of the Gulf of Mexico. This is just all high power return for reasons I'm not sure about. We're not seeing any real echo there. And then we'll talk about this precipitation across Minnesota and into the northwest part of our own state. And as I said, maybe if you can recall from the satellite picture, it doesn't look like it's obviously connected to a well put together cyclone, but we'll see what's driving this, I think, or make some reasonable guesses at it at least. That's all we can ever do. And then here's the heavier rain over southern New England and the middle Atlantic. It's kind of all the way up the coast from central New Jersey into northern and central Vermont, and pretty heavy away from the coast itself. So that's something. And this is where all the rivers in the New England states are. The Connecticut River is here, and then a couple of other ones. So Winooski River. So that's where they can really pick up some rain and cause some problems. So we'll take a look at that and see if we can understand that. Okay. And then a little bit of shower activity associated with that little beast that came across the Oregon coast and is falling apart as it does so, just like the one on Tuesday. So no big difference in terms of that. So we'll try and figure out what's going on with that as well. So first, Pete, can we look at, from here, can we look at a surface map? It'll tell us kind of the intensity of the rain as a confirmation of what we saw on the satellite. And we'll start in New England, if we could. Yeah, so, well,
Yeah, no,
I wish I'd grown up there in New England, but it's not the case. So you can see light rain in Providence, moderate rain north of Hartford. There were places with heavy rain this morning in parts of these locations. A thunderstorm at New York City itself, 57 over 57. So
Did
it's
you
kind
see
of
any of the
tropical
video
there.
coming out of New York?
I did not. I only
Brooklyn
heard
got like 5 inches of rain. There were like buses driving, like water on the roads and
Is that right?
into the buses. Yeah, it was
Yeah,
insane.
that's bad news. So
Yeah,
it's
they
really
really got drilled.
tough for them. So it's, I think, probably more in the western part of the region that the rain is heavy. And at least right now in this last report, just a couple of moderate rain showers. But the dew points are high everywhere, 61 at Block Island. So really, really high dew points until you get into Maine, and even there you get them in the 40s into the low 50s. So this is purely, this is kind of a late summer tropical air, and so fairly substantial threat. It's the kind of day that reminds me when I was a boy delivering papers. My dad would get up really early just to drive us around on a rainy day. And it was really nice of him because he had to drive 35 miles through traffic to get to work. So he did it for us. And these are the kind of days it reminds me of that. Even here, it felt the same way coming to work. So we're going further to the west. Still a 58 dew point for us. As I say, I don't think we've had prolonged period of time with a dew point below 60 in at least this whole work week. So it's really been close to 60 all week long. And surprisingly, it doesn't always feel too humid, but that's just about at my cutoff. If we were down in central Illinois or in St. Louis, God forbid, with the Cardinals at 28 games out of first place, with a 67 dew point, that would be hard. I mean, I remember going to school there. It wasn't until mid-October that you really felt like you could say, God, finally, the summer is over, you know? And even then, you'd get visited once in a while by these kinds of dew points. That's miserable. So, but we vanquished them, we vanquished these guys. Is Kalen here today? I meant to make a public apology to him. I kind of made fun of the Cubs' terrible loss the other night to clinch the division for us. It was the 5th night out of 7 where they had a lead after the 7th inning and lost it. So,
and it was to the Pirates.
Well, it doesn't matter who. It could be anyone. It's the Cubs factor that really is involved here. It's not the opponent factor. So, terrible. But I know you have a particular affinity for the Pirates, who started out gloriously, Mitch, but just didn't have it. It's too bad.
Yeah, don't remind me.
Yeah, I know, sorry. Now I'll make an apology to you.
Thank you.
Okay, so cloudy, it's going to get warm, though. Boy, is it going to get warm, and you can tell. Looking upstream, temperatures are in the mid to high 80s, sometimes 90 across eastern Kansas. You'll see why when we go to the upper level. So we're not done with our summertime yet either. That's somewhat unfortunate, wearing 3 or 4 layers and a tie, but that's just the way it goes. It's an occupational hazard. So let us now go to, well, let's see if it's raining at all off the west coast. I think most of those sprinkles were maybe between stations, but no, I guess not. A little bit along the coast, not quite in Portland, not also in Seattle. Just a couple of reports here in Oregon, eastern or central Oregon, western or central Oregon, and that's about it. So that feature is falling apart, but when we go to the upper charts, we'll try to understand where it might have come from to begin with, and then understand a little bit about its recent demise. Okay. Oh, Minnesota was the one last place. We know it was raining in parts of Minnesota in the radar as well, so slide a little bit over. So we've got light rain at Duluth. We've got moderate rain at International Falls and a few other spots down here in southeastern Minnesota, 60-degree dew point with a little bit of light rain. So I think we saw in the radar activity there was rain in the western part of the state as well, but the sky reports at these 2 stations don't confirm that. So scattered precipitation, occasionally moderate, but not heavy anywhere in that region. So we'll try to understand where that's coming from. Okay, I guess let's start at the 500 millibar map, Pete. The eponymous Super Pete. And so here's our 500 millibar map from this morning. This very weak looking trough feature. Now it's weak only because one geopotential height contour fits in at the contour interval, 60 meters. But the winds are very strongly cyclonic associated with this. And they're 25, 35 knots. So it's not the weakest thing I've ever seen at 500 millibars. It's darn close. I mean, it's in the running, but it's not the weakest. And the temperature here, the coldest temperature is about -16 analyzed at Pittsburgh. No place is colder than that. So this isn't desperately cold area. Now, really to do this justice, which we'll do in a minute, we'll have to go back in time to see where this thing came from. And then the much more robust upper trough is over the western part of North America, particularly Canada, and it reaches down into, sort of northern California and then off toward International Falls in Minnesota. So this is a deep upper trough, a real wintry looking deep upper trough. Temperatures north of the wind speed maxima are in the -20, mid -20, so -24, 25, so forth and so on. So pretty chilly in the western provinces of Canada at 500 millibars. Wind speeds are in the 45 or so knot range and not particularly strong, but you can see this is part of a wave train that is fairly impressive. There's one here that's off the Aleutian chain, that's the storm that's really nicely organized there. I showed you in the satellite. Then there's a downstream ridge, and then the deeper trough, and so on. So you can see where the fall actually is in western Canada. Everywhere south of that geopotential height gradient is still in the summertime. That includes us. as far as I see it. So can we look at a movie?
Yeah.
Where did this thing come from? And we'll click through it. We'll start at the very beginning of this if we could. Because this gets us, last week at this time. Remember we were looking at this feature that had kind of looked more robust on Thursday of last week, and then it was just coming on shore as a cutoff upper trough at 500 millibars and looking like it was kind of falling apart. So let's keep on going. And it was in fact falling apart. We saw that at successive times. This is now into the next week, which we didn't get to share together, so let's keep going. Kind of a little bit of a closed cutoff upper low on the South Dakota-Wyoming border, minus 17 at the core, minus 15-ish air over it, and then we're getting into the early part of our own week. Let's keep going. That feature was kind of sitting over at southwestern Minnesota. You could see in the satellite picture, especially the water vapor image, there was a nice tendril of low water vapor air that wrapped up into the center of this. So that's often a suggestion that there's a little bit of a PV maxima there. Notice this wind shift's 180 degrees across that. So there's more of a trough there than appears to be the case in this analysis, but it's really nicely closed off over western Minnesota late on the morning on Sunday. Let's keep going. Then we had a really rainy, keep on going a couple of clicks at a time, Pete. This thing sat around and gave us clouds and light rain over the weekend, and into Tuesday morning we had a fairly substantial rain event, as I recall. And that's when we had the coldest air, only minus 15 sitting over us. But nonetheless, this thing hung around for a long, long time. And let's keep clicking forward, and you might not be surprised, we can keep going. You might not be surprised that it's this feature right here that opens up a little bit by the time it gets to the East Coast, and that's what we're looking at today. So we were visited by this thing all last week. It didn't go away, it was a bad house guest. And now it's finally made slow progress to the east, and it's responsible for the things we're hearing about in the news today in New York City and some of the other big metro areas. Heavy rain that they sometimes have difficulty contending with. It's not a very impressive upper trough, right? Even though the winds do demonstrate the curvature, but the wind speeds themselves are fairly weak. So an interesting thing here to look at is what's going on at levels lower than this. So let's go to 700 millibars at this final time. Similarly weak, almost non-existent. At 850, not even a trough. There's some cyclonic swirl to the winds over Ohio and western Pennsylvania, but that's questionable. So this thing gets weaker and weaker and weaker as you go to the ground. How about at 300 feet? Oh, that's where the energy is. Okay, so this is a fairly sharp trough, 65 knots at Wallops Island. So this is a fairly sharp trough, very distinct curvature downstream of this curvature maxima. Remember, we're several hours behind what we saw on the radar. That's where the heavy rain was, going across the middle Atlantic up towards New England. So this feature is stronger at upper levels than it is in lower levels. And so, but since it's drawing on air that's got tropical type characteristics, high dew points, probably low stability, it doesn't really matter much where the forcing for ascent is. If it's concentrated fairly high in the troposphere, it'll still get the job done at this time of year. That might change as it gets colder and the stratification intensifies. So that's an interesting disturbance. And I think it actually developed. I won't put you through it, but I looked at it myself. What's the movie at 300 millibars? It looked equally weak a couple of days ago while it was residing over us. This is where development somehow occurred. And that development has kind of reinvigorated the precipitation threat that's associated with that disturbance. So that's an interesting question all by itself. Upper tropospheric development in the right kind of thermodynamic environment can still give you a lot of problems at the ground. And that might be one of the mechanisms by which late summer, early fall, heavy rain events can get generated. I remember once, it was long ago, we got to sit on the sidelines of the football game. You remember this, Andrea? We were going to look at this case. This was when you were first a graduate student, September of 08 or 06. It was a really heavy rain event here in mid-September. And there was nothing in the lower troposphere that would have given you any clue about it. And so we got soaked watching the ball game, my kids and I. And we went home in the bus, but it was too cold because the air conditioning was on. We walked home because we were going to get, I was afraid that we were going to get a cold. We were so wet and the air conditioning was so intense. So it was one of those late summer, early fall tropical days that has a strong upper feature that developed, but not a low level feature. It was really interesting. Maybe too much. Okay, here's the, at 300 millibars, really intense polar jet that is digging down on the western side of this, the eastern side of this ridge. And that, downstream of that, right here, there's this little troughlет That was the thing that's associated with that little swirly we saw coming in on the Oregon coast. But downstream of it, there's no reflexive, anticyclonic curvature, so there's just no hope for this thing to survive its transect across the mountains. It's got nothing to rely on continued divergence pumping aloft. Can't make it last. So it was pretty decent while I was over the ocean. As soon as it comes on shore, it decays away. Okay, let's turn our attention now to the stuff in Minnesota. I found that kind of interesting. We saw it was precipitating there. Let's go to the 500 millibar again for the current time. I didn't draw your attention to this before. Now, right here, from western Wyoming into southern North Dakota, that's a pretty decent wind shift. That's, if you drew a streamline here, that streamline would have more troughiness in it than the geopotential height lines have in the analysis. So that's a key to me, that there's something a little more potent in this flow than what meets the eye when you just look at the computer-drawn analysis. A little bit more of a trough right on the South Dakota-Wyoming border. Downstream of that is where you're going to have your likelihood of forcing for ascent. So I have a feeling there's a little bit more forcing for ascent at 12Z this morning in the eastern Dakotas than was indicated by just a glance at this map. And that whole complex moved into Minnesota. So that's one little clue that there's something going on there that doesn't quite meet the eye. Let's go to 700 millibars. And here it's even a more obvious clue to me. We've got reasonable baroclinicity. Every one of these isotherms is 5 degrees separated, so this is whatever that value is, a 10, 5, 0. So you've got a decent baroclinic zone, and I think reasonable confluence in the northern part of it. So that's going to force the isotopes closer together. The response to intensifying the gradient by horizontal advection is the development of a thermally direct circulation, and the warm air rises. So not only do you have a frontogenetic component in the middle troposphere, probably generating forcing for ascent in this broad region, but at 500 we had a little bit more of a trough generating ascent in the same region. So there's a couple of things working for us at the same time to produce this precipitation that we saw on the radar over Minnesota. Let's go to 850 and see if we can't see further evidence of either one of them. And I think that we do. Here we have a really strong, or I should say a really pronounced warm bubble. Look at these temperatures, 21 degrees at Omaha, 22 in Kansas City area. So this is really warm at 850. And then we have a little bit of diffluence across the warm advection region. So that means you get concentrated warm advection. That sounds like what you need in the QG omega equation, doesn't it? A Laplacian of warm air advection will force the air to rise, not just constant or uniform warm advection. And that's right where we have this stuff going on in southern Minnesota. So next week, Louis will try and tell you all that you should stop thinking about the QG system, and I will, of course, reinforce how idiotic that proposal is. And I'll win again. I won in April of 2011 in that debate, so it won't be hard to win again. So yeah, you should always try and diagnose why things are happening. And the way to diagnose them is to use a diagnostic expression. Don't just rely on the output from the model. You should know whether you should trust that or not, I think. And I think we have good reason to trust it. There's a little bit of a wave back here, that helps. There's mid-tropospheric frontogenesis, that helps. And then there's a long isentrope Q-vector convergence going on in this local region of warm advection, and that certainly helps. So all three of them are working in the same direction to produce that precipitation. So I think we can diagnose that one reasonably well today. So that was kind of neat. Now, we should go to the tropics for a second. Kind of eating into the time here. Just to get a discussion or a description of these two, Philippe and Rena. They're both tropical cyclones. I think they have 40-knot winds. Yeah, 40 knots for Philippe, the same for Rena. Neither of them is going to make any contact with even the small islands in the Atlantic. They seem to be just going straight north, Rena a little bit more to the northwest over the next day or two. So there's no particular threat for any place from these two storms. It is Rena's forecast position, and there's Bermuda, and then Philippe goes a little bit, I think we did, oh yeah, Rena was the second one, sorry. So Rena gets a little closer to Bermuda, but they're both in this area. At sometimes overlapping times. It'll be interesting to watch that this week. But it won't have grand impacts on any land masses, which is, at least for the next few days, that looks to be the case. Okay, now let's go back to the West Coast, and let's go to Alicia Bentley's maps, if we could. We already showed the satellite movie of this thing off the West Coast, which is interesting. But there's your first really dynamic mid-latitude cyclone of the year. It has no obvious tropical connection to something upstream or anything that, 3 days or 5 days ago. It's just a full-fledged well-developed extratropical cyclone. And so I can't get to the central pressure here, but it's in the 970s, and it's very, very intense. Here's the thickness gradient associated with it, that warm front in the near vicinity of the cyclone, and then just a baroclinic zone tied to the jet farther away, and we saw this jet and the upper trough associated with it at 300 millibars just off the coast of Oregon. So that's where you have your slight little sea level pressure minimum perturbation right off the coast, and that's tied to that. So there is some connection here, it appears, in sort of the wave train structure. And then there's an upstream wave as well that's probably also having something to do with this whole train, and that's interesting. But I want to pay attention a little bit to the development and some of the other characteristics of this particular storm. So to do that, let's look at some of the QG omega diagnostics that I have for that storm. And that will be from my own page that you had up just a minute ago. So if you slide down to the Pacific, this is from last night, if we go right there. This is from last night at 0Z. And so yellow are regions of ascent every effectively centimeter per second, and blue are regions of descent, and then here's in dotted white lines are the 500 to 900 thickness. So you see they look quite like what we just saw on Alicia's maps. And then there's the upstream cyclone as well, with its couplet of ascent and descent. So this is really intense ascending motion, really intense descending motion, and this is the total QG omega at 700 millibars. It's fun to split it up into various pieces. Let's first look at what we talked about in 452, 751, the Sutcliffe Trendbirth formulas. So let's go to right there at 0. It's a little more cartoony, I think you'd say, right? Bigger area, more intense maxima and more intense minima, but that's because the Sutcliffe Trendbirth form of the omega equation neglects the deformation terms. Let's see what the deformation terms look like all by themselves. We can do that. So here they are at 0 hour. What? Ascending motion in the region of broad scale descent and descending motion in the region of broad scale ascent. So they completely counteract each other to a large degree. That's why the total looks less cartoony than the Sutcliffe Trendbirth, because you got to add this subsidence on top of the balloon of ascent, and you got to add this ascent to the balloon of descent in the Sutcliffe Trendbirth form. So that's kind of interesting, and that's why we get that much smaller intensity couplet at the other time. One other thing that's neat is the same thing happens with this upstream storm. Remember, this is downstream of the thermal ridge. This is where air is definitely rising, but the deformation terms are working against that. And upstream, where it's definitely the air is sinking, the deformation forcing works against that. Notice, this couplet is oriented at 9 o'clock to 3 o'clock. This one's oriented at like 11 o'clock to 5 o'clock. So this one's been much more intense storm. It's been rotated cyclonically. Everything about it's rotated cyclonically compared to this one. So that tells you just in a glance the age of the disturbances, which is kind of neat. All right, let's, what did I want to do next? Let's split the total now at the same time into, I think we'll just do this. No, we'll do this instead. So you can look at the vertical motion that's forced by the along isentrope convergence of the Q vector, and then that's controlled by the across isentrope convergence of the Q vector. Cross isentrope convergence usually tied to frontal structures. This part here, which is the along isentrope, is not. It's closer to the Sutcliffe Trendbirth form. And you get a 12 o'clock to 6 o'clock orientation of ascent and descent. That looks a lot like the total that we saw before. Clearly, the lion's share of the total comes out of this term. Let's do the only other piece that adds to make it the total, and that's the transverse at 0 hours. This thing, though, shows the frontal structure kind of nicely. So here's the thickness lines. Warm front, cold front. Here's the ascent with the cold front, descent with it, ascent with the warm front, descent with it. So it's all kind of put together, and you get a little bit of intense vertical motions from the conjunction of the two frontal structures right near the cyclone center. So that's interesting. In class this week, or 2 weeks ago, I guess we were talking about local energetics and the notion that one system in a wave train can have an impact on another one, can have an impact on another one. And the way they do that is by fluxing energy downstream. But the cool thing about the local energetics perspective, by Olansky and others, is that it does tell you something about energetic relationships between consecutive storms. That's neat. What I find most interesting about it, though, is that there's only one process that creates new energy on the cyclone scale. Other processes on the very larger scale can also do that, but we didn't talk much about them in class. But on the cyclone scale, the only one that can do it is the baroclinic conversion. And that depends on warm air rising and cold air sinking. If that is systematically occurring, then you can have production of eddy kinetic energy, which you can then, it's available to flux downstream and affect downstream disturbances. The cool thing here is, can we go back to the prior panel, the shear-wise vertical motion? Though this is the largest part of the total vertical motion, the air that's rising vigorously here is no warmer or colder than the air that's sinking right here. So this couplet contributes next to nothing to the production of eddy kinetic energy. Let's go back to the one we just had, the transverse, which shows more of the frontal structure. Ah, wait a minute. This air that's rising is in fact warmer than this air that's sinking. This air that's rising is warmer than that air that's sinking. This is showing you a thermally direct circulation around the whole cyclone. So this smaller fraction of the total vertical motion is what's doing the energy ingestion or creation for in the barochromic conversion terminal. So it strikes me that development of cyclones, which is controlled by the other term predominantly, doesn't contribute much to the energetics. It's just kind of along for the ride. You're producing these storms. The storms themselves then, for reasons we'll talk about later in class, produce the structures that are frontal structures, and then the attendant thermally direct circulations. But the development itself does not energize the flow. It's the frontal vertical motions that energize the flow. That's really cool, and we got to investigate that, because there's something that's quite neat about that, I think. Okay, so that's about all I have. We could go to other times and watch this thing develop, but we caught it at a pretty good time, near the peak of its intensity. And you can have some fun looking at various parts. Oh, one more thing I did want to show, Pete, and that's the difference between the shear and the curvature vorticity advection. Because the Sutcliffe-Trenberth form of the omega equation depends on advecting vorticity by the thermal wind. That's the only term that's involved. But vorticity comes in two varieties, shear or curvature. So it's always been of interest to me, are there storms that are dominated by shear vorticity advection for their development? Are there storms that are dominated by curvature vorticity? It's never been very clear. This is a good example of one that is. Here's the shear vorticity advection at the same time. Not insubstantial ascent in that region where we saw the total ascent, and not insubstantial descent. So that's all accomplished by advecting shear vorticity. Let's look at the curvature piece, just below it. Oh, that's the lion's share. In both this storm and the upstream storm, the lion's share of the vorticity advection, which is responsible for development, is advecting curvature vorticity. I contend, and I haven't proven it yet, that there are storms that have the opposite predominance, that there's going to be storms where the shear vorticity advection far outweighs the curvature vorticity advection. I don't know how those storms differ in terms of their life cycles, what environments they might form in, and what sort of precipitation distributions they might have. But those are all interesting questions. And so I'm on the hunt, and I have to think of a analytic way to do it. I'm on the hunt to try and find examples of this one's curvature dominated, and then the counterpart shear dominated ones. And I think the only way to do it is just look at a whole bunch of them over the course of several winters and just do it. So anyway, that's all I have for today. Patrick? Perfect.
Thank you. So I'm going to start with looking at the drought over us, and then briefly touch on New York flooding, and then I'll finish with this storm will have implications on our weather further down the week.
I have my email on one of these. There it is.
So I'll start at the very first one, please, and scroll down to precip. So we got about 2 inches of rain in this event that happened from Sunday to Wednesday, and so that has put us now about 5 inches below what we should be at, and the calendar water year ends tomorrow. So this map will be updated and will be on the far other side, but we should end up 5 inches below normal, which is much better than what we were before, which is about 8 or 9 inches below normal, thanks to that low pressure that is now affecting New York. So this is a good sign, and it has implications for, if we could go back and go to the drought really quickly, the next link I have. And we'll click on Wisconsin, please. And this look will be good enough. So we focus on Wisconsin here. We are no longer in exceptional drought. We had 2 areas around Viroqua and then up Bayfield. Both of these regions are now in extreme drought at worst, and we are currently in Dane County in a moderate drought. And I went back, you have to go back to June 20th of this year for us to not be in a worse than moderate drought, severe or extreme. So it's been about 3 months of pretty bad drought conditions for us. This is a good sign, however, we'll look at the QPF and it might show that we might not continue to get rain. So we did get a burst But if you want to break a drought, you need a bunch of little rainstorms in a row so the soil doesn't dry out. That doesn't look like is going to happen, at least in the near term for us. So could we go back, go to the next link, which is, we'll look at weather.gov here. And so this is a look at the current watches and warnings and advisories. We can notice here's the flooding going on around New York City and stretches down into Delaware. There's some, let's see, red flag warnings in Louisiana, around Phoenix, and then into the mountains in the west. And then this is a winter weather advisory, so there is snow happening in California, but the only place, as Professor Martin pointed out, that winter exists is along the west coast right now, particularly in the northern part of the west coast. But if we could click on New York region, and I'll just point out what's going on. So there's a ton of flood warnings, advisories right now. This flash flood warning has been going on for 8 or 9 hours at this point. They've gotten some places up to 5 inches of rain, and it's still raining. You can see on the radar. There was a nice band that just went straight north. It looked like right into New York. And that is leading to, if we go to my attached screenshot from the map, email right there. I saw this interesting tweet this morning. So this is your fun fact for the Friday. New York City sewer capacities can handle 1.75 inches of rain per hour and not flood. So this is a look at how many hours the rain has exceeded this capacity. And this is from 9 a.m. this morning. But you'll notice over Brooklyn, there's been at least 2 and probably 3 or 4 hours consecutively of rain that's heavier than this capacity for the sewers to handle. And that is leading to all the videos of, you know, the rain just coming up out of the sewers, buses flooded. I'm sure the subway system is a mess right now. And you can notice it's pretty widespread region where their rain has been higher than what the sewer can reasonably hold and distribute. I'm not quite sure how it does that, but so this will be a significant event. It looks like it's still ongoing, so we might see this throughout the entire day, and there might be rainfall totals close to 7 inches by the end of it in one day, which you put that over a heavily populated city and you have bad news and a ton of media coverage, which we'll probably see. Okay.
Nick Basil's a graduate of our program.
Yes, that's right.
2 or 3 degrees at least.
I wanted to add
Oh,
on
yeah.
to that. So Nick is now working for the New York State Measurement, so that's this graphic. But I'm messaging with him right now. And one of the things that he just told me was that New York City, which has just hired a meteorologist to be on staff to work with the emergency management departments and communicating everything, they just told the New York City Port Authority to expect at least 3 to 5 more inches of rain. Don't know if that's true or not, or if it will happen, but New York City is preparing for some pretty bad things.
Wow.
Yeah, so far.
Right. Can we go back to this weather.gov page? Forgot to mention. Can we go back one click and we'll look at the QPF down here in Outlooks. Right there. So that QPF. Okay, let's see. So this updated, I guess. And now this starts, that's unfortunate, I should have saved it. But this starts at like 5 or 6 p.m. local time. But this morning, this was issued at 7 a.m. So this was after some of the flooding had happened. New York was in a bullseye for like 7 inches of rain. And that sort of fits with expecting 2 to 3 more inches. This even shows, 1 to 2 inches, which is still a significant rain event, especially when you've had 5 inches of rain already. So this will be something to watch for sure. And we can just hover over the day 1 through 7. We'll look at a week's worth of forecasted precip. Here's our bullseye over New York. Over us, we're largely unaffected by any systems. You can notice maybe something is moving along the central United States, which we'll look at. And then the western United States stays generally rainy. We'll also touch on that. But we kind of are in this middle range between, here's our coastal low right now, and then a system will move in later on in the week, but we're largely unaffected, and we stay sunny and hot. Which leads me to my last link here. We'll look at our GFS page here, and we'll start at 500 hectopascal. We can start at this.
That's the old version. Did you want to do?
I like this one, yeah, we can do this one. So this is a look at this morning from the GFS, and we see some of the same things we noticed on the upper level charts. We have our trough and the associated low out ahead of it. Here's our gigantic system over the Gulf of Alaska, and we can watch, and we'll click through this. If we go to 24 hours ahead at 500, we can notice this storm sort of lingers, and we'll watch this downstream ridge become more intense. And what that does is you flux energy downstream, and you deepen. Now we have a pretty substantial trough over the western United States. And if we could go back, and we'll look at a surface map from the same time at one day. And so that dip in the 500 geopotential heights is associated with lower thickness. It has to be. And we can see that in the thickness contours here. And there's a general area of low pressure that begins to form in the contour lines. And out ahead of it, you have a gigantic trough, so you might expect a ridge, and we stay in the warmer thicknesses out ahead of it. If we could go back.
Just one thing about these maps, Patrick, I would be wary of the precip, because sometimes it's a 12-hour and sometimes it's a 0 until now.
Okay.
Because of the way the group files are formatted. That's one of the reasons I did the Python maps, was because this doesn't.
Oh, gotcha. Okay.
There's not a good way for me to say plot one or the other.
Okay.
But you wanted which?
If we could go to 500, we'll go to 2 days. We'll see here's our ridge. We're hot. We stay hot. Here's this deepening trough. It becomes wrapped up, so it's not going to produce any significant development out ahead of it, and we'll see that in the surface map. But here's our area of cold air. And if you're like me, I like to look at my phone weather app to just get a glance of the temperature. If you look at that, Thursday and Friday of next week, we're supposed to be in the 50s. And so if we could go back, and I'll just step through, I'll just go to 5 days at 500. We can see here's our trough. It's very symmetric, but underneath this trough, you can expect thicknesses will be pretty low. And this is Wednesday morning now. If we could go back one, and we'll just go to Thursday. I'm going to do that one. 6 days. We'll see we're kind of in the center of this trough. Out ahead of it, we might expect some ascent and precipitation, and I believe that is what that feature was along the central United States we saw in the QPF. But if we look at the same map this time, 6 days, and we look at our surface, we'll notice here's our thickness as 542, which if you, general forecasting rules, some people think 540 is the line between rain and snow. So we're sort of in very close to the center of very cold air, which extends all the way up into Canada. But these are incredibly low thicknesses. And this is Thursday morning here. It looks like rain out ahead of that trough. Not really tied to, maybe tied to this low pressure system, but we're sort of in the trailing cold front that stretches all the way down to Texas, it looks like. And if we go back and we'll just look at the surface for 7 days, and this is what I'll end on here. We are right in this bubble of the coldest thicknesses anywhere in the United States. So Thursday and Friday might be pretty cold. We might get down into the 20s even. Something to watch. Might not develop as this model forecasts. This is only one model. But we do get some rain out ahead of this trough, and then we get very cold temperatures. So it might start feeling like fall after we get warm up and we are in the 80s. And then right behind it, I did notice this. Here you have very strong cold air advection associated with this pretty strong cyclone in Canada. So we might see a pattern shift. Once we get this cold air, on the back side of it, here's more cold air moving through. Might stay in the 50s, and we might continue to see that. but this is pretty far out, and this storm will probably not be exactly what is forecast here. But that is something to watch. If you want fall, wait till Thursday, and then you'll be happy. And then we might see more fall right behind it. Yeah.
I was gonna say, this week I noticed on some of the long range models, it started spitting out the like solutions for like snow events, which kind of shows that there's like that type of pattern, obviously too far out.
Right. Right. I mean, just from this look, you could expect snow in southern Canada. This is pretty far south compared to where we've seen snow, which is way north towards Greenland. So, yeah, we might see, this might be our first snow event. Let's actually look, if we could go back, let's just see if this cold air, let's try 8 days, please. Here's 540 line in the darker yellow. So this might be snow creeping up Saturday morning in northern Minnesota, maybe even northern Wisconsin here. Maybe even a rain-snow mix, but here's our shot of winter, and this is pretty strong cold air advection with isobars indicating the wind, and then we have cold thicknesses to our north, so this would be pretty strong cold air advection for Saturday morning. This might be when we get into the 20s potentially. Looks like our coldest night for the next week or 2 weeks. So this will be something to watch for sure.
Homecoming football game that day.
Yeah.
Yeah, man's got to play
And it's
outside at 8:30.
Yeah, it's at 11 a.m. So
20 degrees.
I'll inject a little bit of realism. And it's not often that I do this, but what I'm excited about is the snow in Canada. I don't
Yeah.
care if we see a flurry here next weekend. It would be great if we did, but if we don't, I don't care. I like to see the snow being placed in southern Canada.
Yep.
In central Canada, because that means you got a radiative blanket that makes it harder to stay warm.
Right.
And the flow comes from the northwest, you know what it means.
Right.
So I'm excited about that. This is a little early for that snow to be put down. I'd like it even further west. I'd like it in British Columbia and Alberta, not in the adjacent provinces, but you can't get it what you want.
And
So try sometimes to get what you need.
Yeah, we're getting what we need, that's for sure.
I know the precip is not reliable thanks to Pete, but seeing precip appear in southern Canada where we saw those fires is also a good sign. Potentially relief, hopefully relief. They definitely need it. So are there any comments or questions? Perfect.
All right, thanks, Patrick.
Thanks,
Thank you,
everybody.
Pete. 11 o'clock next week, not 12.
Okay.